Hi everyone, Miss Donaldson here. Today we're going to talk about scientific notation. As you guys know, this is the way that you can write really large numbers and then really small numbers. So let's go ahead and jump into it. So scientific notation, when you write it, it must have the following parts. It must have a number that falls between 1 and 10. That first number cannot be larger than 10, but it cannot be also less than 1. If it falls in between those two numbers, then you're fine for the first number. It must also have a multiplication sign, because technically with a notation, what you're doing is you're taking that number and then you're multiplying it by power of 10, which is the last thing that you must have as for in scientific notation. So for the example here, that's on your notes, the 6 and 2300ths, that is your decimal notation. So again, it falls between 1 and 10, so we're good. It also has the multiplication sign. And then last but not least, it has the power of 10. When I say power of 10, 10 will be your base, and then you would then have an exponent. So it makes it a power of 10. Now, let's get into some converting. Again, today our EQ was how do I convert numbers to scientific notation. We're going to work going both ways. We're going to work scientific to standard, or just your normal form of your number. And then we're going to work backwards, going from standard to scientific. We're going to first start with converting scientific to standard. So in our example, I have 1 and 56 hundredths times 10 to the fourth power. So let's check it to make sure that it's written correctly in scientific notation. I look here, the 1 and 5/6. That number falls between 1 and 0, so I'm good on that front. I have a multiplication sign, and then I have a power of 10. So my number checks off that it's written correctly in scientific notation. So let's look at this and look at a couple of steps. When you're writing in scientific, it is important to look at your exponents, because that's going to tell you which way to move and then how many times to actually move. So when I check my problem here, my exponent is 4. It's a positive 4. That is important. If your exponent is positive, we're going to, and also add this to your notes as well. If your exponent is positive, you're going to move towards the right. So on the other hand, if my exponent is negative, I'm going to move towards the left. So again, that is why I say that it's important to know to look at your exponents, because that will tell you two things: where to go, and then also how many times to move. So when I'm converting, I'm going to start with that decimal notation. So my decimal number in that is 1 and 56 hundredths. Now, looking at my exponent, it is a positive 4. I know that because it's positive, I'm going to go towards the right. Then I'm also going to go 4 jumps because my exponent was 4. So I have to, step 1, first move your number's decimal right as many times as the exponent tells you to. So my decimal is here, so I have to move that 4 times. So 1, 2. Now, I've only moved twice and I am out of numbers. Step 2 says that if you run out of moves, you're going to add zeros. So I'm out of moves. So I add one more move, that makes 3. One more move makes 4. So my answer for that particular problem is 15,600. Now, while it's still fresh on our minds, let's jump over to the iBook practice, and let's work these problems out here together. So again, I'm writing these in standard form. So I'm going to start with my decimal number, which is 7.1. Now, looking at my power of 10, my exponent is positive. So I'm moving again towards the right. So I'm going to write right out beside that. I'm moving my decimal the number of times of my exponent. My exponent is 3, so I'm going towards the right 3 times. 1. I've jumped 1. I'm out of moves, so now I'm going to add zeros. 2, 3. So my answer will be 7,100. Let's look at number 2. Write my decimal notation, which is 6 400ths. Now, look at my power of 10. My exponent is a positive 5. So I'm going to move towards the right 5 times. 1, 2, 3, 4, 5. So my answer is 604,000 is my final answer. So number 3 of our practice problems, I am going to, again, 9, write my decimal number, 482. I look here, my power of 10. My power of 10 is 4. So it's positive. So again, towards the right, 4 times. 1, 2, 3, 4. So that gives me 91,482. Now, I realize that all of your examples in your iBook are positive. You don't have it on your iBook practice. I just want to do one negative with you so you can look at the difference. So let's make this up. I'm going to go example 1 for your negative numbers. If I gave you 6.72 times 10 to the negative 4th power. Now, if you recall, going back to the our organizer, if your exponent's negative, we're going to move towards the left. So let's go back to the example. My exponent's negative, so I know I'm going towards the left. I'm going to write the decimal number. Now, I'm going to find my exponent. Again, it is negative, so I'm going towards the left. I'm going towards the left 4 times. 1, 2, 3, 4. And again, I put those zeros as placeholders because I ran out of moves. So I'm left with 0.000672. Now, let's look at this. If you'll notice that when my exponent was negative, my number turned out to be a decimal. If we go back again to our examples, these powers of 10, their exponent was positive. These numbers end up being greater than 1. This goes back to if you guys remember last week we did properties of exponents. Remember, if your exponent was negative, remember we said we had to flip it because it formed a fraction. So again, this supports the theory of why we flip it, because you notice that your negative exponent actually forms a decimal. And you guys know that decimals are equivalent to fractions. So yeah, let's look at the vice versa. Let's look at going from standard to scientific. So what you're going to do is you're going to take your number and you're going to find your decimal. Now, if your decimal is a whole number, you know that your decimal is at the end. You're going to have to adjust your number until it forms a number between the 1 and 10. Remember, 1 and 10 were our 2 magic numbers as for scientific notation. So on this example here, my decimal is actually back here in the back. So I'm going to move 1, 2, 3, 4, 5, 6. So I moved 6 places. This gives me 2.407. Now, let's talk about why I actually stopped there. If I move once, that number is still greater than 10. I move twice, still greater than 10. Move a third time, still greater than 10. A fourth time, still greater than 10. A fifth time is still greater than 10 because that's 24.07. If I moved one more time, that decimal is technically here. So that gives me 2.407, and that number actually falls between 1 and 10. So when I count my moves, it was 1, 2, 3, 4, 5, 6. Now, I know my exponent is going to be 6 because I moved 6 places. But to determine positive or negative, I'm going to look at my number itself. Now, remember, we just discussed, not even a minute ago, that we look at the exponent to determine if it's going to be positive or negative. So, when I looked at my exponent at the other example, they were all positive. And those numbers were all greater than 1 whole. When it was the negative, when I did that example, remember, it formed a fraction. So since here, my original number is greater than 1 whole, so that lets me know that my exponent needs to stay positive. Now, had my number been a decimal, then my exponent would have needed to be negative. So, going on, one thing I gotta ask you something. If you look at the blue, what's highlighted in blue, those are outside zeros. Once you move it and you found your number that's between 1 and 10, you can actually go through and drop those outside zeros because they're what you call placeholders. We don't need them. Now, I can drop, let me highlight this. I can drop these zeros, but I cannot drop this 0. And I'm going to highlight that a different color. I cannot drop that 0. This 0 here has to stay. If your 0 is between two numbers, then it's not a placeholder. You can only drop the zeros at the end of the number. Now, let's go look at the remainder of the question. So, how many places did you move? So, I moved it, we said, 6 times. Since I moved it, still highlighter. I moved it 6 times. So, the exponent, again, because my original number was greater than 1 whole, then my exponent has to be positive. My exponent has to be positive. Okay, let's continue working. So now, let's continue working these iBook practices. So, we've already did one part of the iBook practice, going from scientific to standard. Let's look at one more of that kind, and then we'll work on the vice versa. So, if I look here, it says circle the examples that are correctly written in scientific notation. So we're going to look at each example and talk about what we notice, and then whether or not we agree with that particular what they have written down. So let's look at the first one. If I look at this one here, 6.2 times 10 to the 8th power. Let's check and make sure that it has those 3 parts that we discussed in the beginning. My decimal notation part of that is between 1 and 10 because it's 6.2. I have the multiplication sign and a power of 10. So I can circle that because that is written correctly. The next one, 1.29 times 10 to the 5th, I can also circle that. Because again, that falls between, the first number falls between 1 and 10. Is multiplied by a power of 10. I can also circle this one. 5.407. That, again, that numbers fall between 1 and 10. Oh, my fault. Miss Donaldson did not catch that before I circled that. That cannot be circled. I looked at it incorrectly. this cannot be circled because look at my power of 10. Is it really a power of 10? No, it's not. It is a power of 20. So that base of that exponent has to be 10. So that one should not have been circled. So please make sure you go back, and if you circled it, make sure you erase that. Let's continue. This one, the 7 times 10 to the ninth, may also be circled because that is, again, between 1 and 10, and multiplying by a power of 10. And the last one that can be circled is this one here. Again, that number falls. Now, although it's 9 and a decimal, that is still between 1 and 10. So I can circle it because that is correct. Times 10 to the fourth power is multiplied by a power of 10. So let's discuss the mistakes we noticed. So and I'm going to actually box those in red and tell the difference between them. If I look here, that is incorrect because of the first number. That number is 13.8. That number does not fall between 1 and 10. So I'm going to write that down so I'll have it. Doesn't fall between 1 and 10. So that is the reason why that is incorrect. If I look here, we've already discussed this one. Remember, I circled it by accident. That is not because not a power of 10. Not a power of 10. And then the last one, again, although it's a power of 10 at the end, it does not fall. It's greater than 10. It is greater than 10. Okay, part 3 of the iBook example. So again, now we're going to vice versa. We're starting with the standard, and then we're going to scientific. So I'm going to write my number down. Then from here, remember, your decimal point is at the end. You have to adjust your decimal until your number falls between 1 and 10, and then you drop any extra zeros at the end. If I jump one time, that number is still greater than 10. Still greater than 10, still greater than 10, still greater than 10, still greater than 10. So that is between 1 and 10, excuse me. So this gives me 7.31. These zeros at the end, I can drop because those are just placeholders. Now, I know I need to multiply it by a power of 10. To get my exponents, I count my jumps. 1, 2, 3, 4, 5. Since that number is greater than 1 whole, I know my exponent is going to be positive. So that's my final answer. On the second one, 5, 2, 0, 0. And then 0, 0, 0. Decimals here. 1, 2, 3, 4, 5, 6. So 5.2. Again, I can drop those zeros times 10. And again, I jumped 6 places. It's going to be a positive 6 because it's greater than 1 whole. 1, 0, 5, 0, 0, 0. Again, the decimals at the end. 1, 2, 3, 4, 5. 1.05. Those are gone. Times 10 to the 5th power. Again, since that is it's greater than 1 whole, then the exponent is going to be positive. And I'm going to do one that's negative, since there wasn't one in our examples. We'll go 0.0735. Now I actually have a decimal point. It's not the end. I have to move where my decimal point is. So I need to move my numbers adjust my decimal to where it falls between 1 and 10. No need of going towards the left this time because there's no more numbers. All my numbers are towards the right. So I know I'm going that way. If I hop one time, that's not between 1 and 10. It's still less than 1. I hop again, I can stop there because that gives me 7.35. As before, those zeros now become placeholders. They're at the end. Now, since my number originally was a decimal, it was less than 1, so I know that my exponent has to be negative. Remember, positive exponents give you a number greater than 1, and then negative exponents give you a number that's less than 1 or decimal. Since I hopped 2 places, it's going to be to the -2 power. Alrighty, guys, so we've gone over, again, converting between standard and then scientific and then vice versa. Remember, if you need to go back and rewatch the video, please feel free to rewind it. If you are in the heat group, make sure that you're going through and you are marking through, and you may use your videos to complete your activities for the week. Talk to you guys later.